So good morning, everyone. My name is Peter MacKenzie. Thank you, Sam, for the introduction. If you want to follow me on Twitter, I am MacKenzie Wi-Fi. You know, I hope everybody appreciates the picture this morning. We all like to get the face off the caterpillar cake, don't we? We all like to eat the cake of the caterpillar cake. That was me enjoying it once, but the problem is with eating the cake, the face off a caterpillar cake, is only one person can have it. So it's always nice when you get it. How does that relate to what I'm going to talk about? Not much at all, but I just thought I would share that picture with you. What do I want to talk about this morning? Well, if you were to ask 10 CWNEs, Certified Wireless Network experts, how to design a wireless network, you would get 10 different answers. And I think as we think through that sort of statement, which you may have heard people use before, I've said it before, why is that? And also, if these all experts won't just give 10 different answers, if you get them all in a room, they will probably discuss, debate, argue that they are right for the next 4 or 5 hours. So my question is there really such a big divide in the industry? Or maybe are they all arguing the same thing? Just using maybe different language. See, I actually believe that most people, most sort of experts, believe the same thing and actually probably all agree. It's just they end up arguing over words and language. But the problem with that is I think it's actually damaging our industry. It's really damaging when you've got new people coming into the industry trying to learn how do I design a wireless network. You know, I teach many wireless classes, teach the how classes, and through teaching, I mean many people who are just trying to learn Wi-Fi. They want to, and they have a desire to design good Wi-Fi. So I'm not talking about people who maybe, I don't know, don't want to do good Wi-Fi design. They just want to throw things in and they're not too bothered. I'm talking about people who their intention is to design good Wi-Fi, but they're being confused by the conflicting opinions and voices that they have in the industry today. And that's what I think is damaging our industry. So what do we do about it? Well, there's one organisation, the Wireless LAN Association, that is actually trying to create a standardised wireless LAN design framework, which some days, I'll be honest, feels like an impossible task. And, you know, I've got to wonder sometimes, can you get a consensus on wireless LAN design? Is that even possible? And my role as president of the Wireless LAN Association over the last few years, I've been involved in many discussions, debates, even heated arguments about how do you design a wireless network. And if I'm going to be honest, I think a lot of these debates have been ridiculous. It's amazing how you can waste hours arguing about nothing. Now, I'm going to try and demonstrate how we can do that in a little bit, but you see, I do believe it's possible to create a standardized design sort of framework, a framework which we can all design wireless networks to and that we can agree on. And I think if we can do that, we can further the industry and help people to design good Wi-Fi. But if we're going to do it, we're going to have to leave our egos at the door and actually come up with a consensus that we can agree on. So to help demonstrate this point, I've got a few polls and questions that I would like us all to partake in. Some of them you might feel the right answer isn't there, but it's just try and answer them anyway, because I'd love to get a feeling of what people think. So the first one is hopefully quite an easy one. We're going to have that poll opened up. So if you go and look at it, it's asking basically true or false, defining the requirements should be the first step of a wireless LAN design. So I'd love you all to have a look at that poll.
Just give people a few seconds to vote on that.
Yeah. So once we've got a few answers, we'll see the results and we'll see what you think.
Give people 10 more seconds.
Yeah.
Okay. So I'll share the results of that one. So we've got 97% said true, and 3% false.
90. So it's quite a big result, though, isn't it? That most people agree on that. That actually the first step of a wireless LAN design should be defining the requirements. So I think that goes to show that actually we can agree on certain parts of wireless LAN design, can we? We can agree that actually most of the time, I think most people here agree that the first step should be defining the requirements. So that's what I mean by the fact that we can agree. What do I mean about ridiculous arguments? Well, let me try and ask another poll question and see if we can all agree on this. So second poll question we will have up now. And I'm asking which statement is true regarding requirements gathering.
Okay, I've just launched that, Peter.
Perfect. So have a look at the options there. So I've got that we must gather both requirements and constraints on that question. We only gather requirements because constraints are requirements, or we gather requirements and constraints are imposed on us. Or you can just say what's requirements gathering anyway. Quick poll. Be interesting to see what your opinions are on that one.
Still got some votes come through. 5 more seconds.
Right.
Okay, and we'll share the results of that one. So we've got 64% of people saying you must gather both requirements and constraints. 21% say we gather requirements, constraints are imposed upon us. 13% we only gather requirements, constraints are requirements, and then 3% what is requirements gathering.
Brilliant. So we're a little bit more split. Now we get down to the nitty-gritty. We all agree that requirements should be the first thing we do, but actually, when we start talking about constraints and requirements, is there a difference? We start to become a bit more split. But actually, and I've sat and debated it. So, but it's a ridiculous argument. Does it matter how we express it, so long as we communicate clearly the information we need to get during the government's requiring stage, providing that's communicated clearly with the customer and with, if it from a design framework point of view, that needs communicated clearly what we require. Does it matter whether we call them requirements, whether we call them constraints and requirements? It doesn't really matter, does it? But people get to a point where they get so obsessed with their language and their way of expressing things that they just can't see other people's points of view. You know, yes, we need requirements and constraints. Maybe constraints are requirements. It doesn't really matter. You know, if you said one of the things that the person who wants you to do a design for them is saying, we had to use a particular vendor for the wireless LAN, where a Cisco shop, let's just say, to pick a vendor, and you've got to use a Cisco AP. Well, is that a requirement to use a sister AP, or is it a constraint? Does it matter? So we often argue over language when it doesn't matter. However, having said all of that, words are actually really important. We shouldn't argue over unimportant words where it doesn't really make a difference which one we use. But the problem is it's all about communicating clearly. So if our words stop us communicating clearly or put about a wrong idea, they're the words we need to stop using. Let me give you a quote I've seen, not just from one person, but I've seen written lots and lots and lots of times. An AP on a stick survey is always more accurate than a predictive design. Now, I think this sentence and quote is rubbish. Why do I think it's complete rubbish? Well, I will be honest, I do AP on a stick surveying sometimes, but I mainly create RF models and do what some people would call a predictive design. And I can guarantee that the way I do design is more accurate than how a lot of people do AP on a stick survey. Now, before you shoot me down with that statement, let me explain what I mean. When I do a predictive design, which I don't like the word enough, I go on site, I measure the attenuations of walls. I will actually put AP up on a stick to take measurements as well, and I collect lots and lots of RF data and measurements, and then put that into an RF model and create a design. Now, how could that possibly be more accurate than how people do an AP on a stick survey when we actually measure it? Well, an AP on a stick survey is only as accurate as the person doing it. So are you accurate in where you click? Are you trying to get to the pub? So you're running a bit too quick and therefore not allowing your survey tool to scan all the channels before you move on. There's lots of ways it may not be accurate, but let's say you're really diligent and you do a good job. The way a lot of people do AP on a stick surveys is they walk to, let's say they've got a -65 coverage requirement, they walk to, let's say, it says -65 or maybe -67, and then they stop. And that's how much of the AP on a stick survey they do. So they have no idea how far the code channel problem is potentially going to be. How far does that channel spread across the building? Whereas if you do create an RF model, we can model how far the signal goes across the entire building. And if we want to look at code channel problems, we can do that. That's something which we often can do with AP on a stick surveys, unless you want to literally survey an entire floor for every single place. Now, this isn't me beating up an AP on a stick survey. I think you can do very accurate AP on a stick surveys. I'm just trying to say is it's not always more accurate than doing a predictive design. And that's one of the issues with this statement is the word always. I don't like it. The other thing is people who say this probably don't mean the way I design networks. What they mean is someone who's taken no measurements at all and they just randomly putting APs on a map somewhere, or they're guessing what the wall attenuations is, and you've got garbage in, garbage out. Now, in that scenario, AP on a stick survey is always more accurate than predictive design. So it depends what you mean by that word, predictive design. And that's, again, another problem with this statement, is that it means different things to different people. You know, you can do AP on a stick to create a predictive design or to validate a predictive design. So there's lots of elements of this statement that don't make sense. The problem with it is it gets said by one person and then repeated by someone else, and then you go to do a design for someone, and in their sort of RFP or in their requirements document, their tender document, they say you have to do AP on a stick And someone who doesn't understand Wi-Fi starts dictating what method you should do because they've seen statements like this. So I don't like statement like this. So how we speak is really important, but we shouldn't be precious about our own methods and words of talking. I think that's also quite important. Now, so when we're talking about different methods of doing design, we should see it as they're just all tools in our design toolkit. We can do AP on a SIG, we can measure wall attenuations, we can do RF modeling using Akahau Design Pro software. We can do spectrum analysis. Do we always have to do one of these methods? No, it depends what the job requires. Sometimes you can go on site. During COVID, we've had to, for some people, do purely predictive sort of RF models because we've not been allowed on site. And that, but providing the customer understands what the fact that that's gonna, what issues that's gonna have, and that's communicated clearly. Providing it's communicated clearly is what all the flaws are with that and what the sort of risk is associated with doing that, that's okay. And maybe we mitigate that by saying, post the installation, we'll go on site and do a validation survey, and we can fix issues then. So different jobs, different roles require different things. There's not a right and wrong way of designing. There's just a set of tools we have. So let's stop arguing about this is better than that, or this is better than this. Let's say these are the tools we've got. Let's understand the relevant merits of each one and understand the risks of using each approach. Going to come to my next poll now. What is a site survey? Now, don't let this picture influence your answer. This is just a picture of some great Wi-Fi tools. But what is a site survey? Let's go for the next poll and have that up. So you've got a few options there. An on-site RF survey to validate RF coverage, the process of creating a wireless LAN design, an AP on a stick survey, or the collection of on-site RF data such as wall attenuation, or none of the above. There are your options. What is a site survey? We'll give you a few minutes to answer that poll.
Looks like we've got quite a split on this one, Peter.
Oh, brilliant.
Give people a few more seconds if they're trying to think what they want to answer. Okay. So 36% think it's an on-site survey, RF survey to validate RF coverage, 30% collection of on-site RF data such as wall attenuation, 21% process of creating a wireless LAN design, and then 1% think it's a straightforward AP on a stick survey, and 13% saying none of the above.
Brilliant. So a complete split. And you know, if you asked me what is a site survey, I would tell you I don't know, because it's a term which has got so confused. To me, it has to be something you go on site to do and you survey, but it's a term which people use for so many different things now, isn't it? To me, it's a confusing terminology, and we shouldn't use it. You see, someone phones me up and goes, Peter, we'd like to come and can you quote for a site survey? And the first thing I'll ask them is, yeah, could you tell me a bit more about what you want? Because I've got no idea. They could be asking me to do a wireless LAN design for them. They could have a network that's got some problems and they want me to go and assess that wireless network and tell them why they're having problems. They could have had maybe a wireless network installed and they need someone to validate that it matches the design and the requirements. All of those activities people refer to as a site survey. And it's become a really, really confusing term, and therefore one that's not helpful, I don't think, in the industry. And this is what I think we need to do, is move away from these confusing terms. So what are some better language for this? Well, These are some language I would like to propose this morning that we use it. Wireless LAN design. If you were designing a wireless LAN network, you were doing a wireless LAN design. You may go on site and do some survey work. You may do AP on a stick. You may do RF modeling in Ekahau, but you're doing a wireless LAN design. So let's call it wireless LAN design. Let's not call it a site survey, because that's not what we're doing. We're designing a wireless network. After the installation of a wireless network, we may go on site and do some validation work. So let's call it wireless LAN validation. When we go on site and we validate that the deployment is meeting the design and meeting the requirements. That's what we do when we validate. And then the other type of work we often get asked to do is we've maybe not done the design, we've maybe not done the installation, but there's a network and it's maybe been installed for quite a while and they're maybe having problems or they don't think it meets their current requirements, so they ask us to come in and do an assessment of the wireless network. Now, an assessment and validation might have a lot of the same activities. You may walk around and you might use Ekahau to measure the RF coverage. But the object is a little bit different. One you are assessing and the other one you're validating something that's already been installed. So I think this language is better. And when someone asks me for a site survey, I try and work out which of these three categories it fits into. And I try and use its language because I think it's clearer and easier to understand. Just while we're on the term of confusing language, I'm not going to spend a lot of time on this. One of my personal favorite topics is co-channel interference versus co-channel contention. Now, you may ask the question, well, Peter, you've just said we shouldn't argue over language. And if anyone's had me talk on this topic before, we should call it co-channel contention because that's not co-channel interference. The problem is, and for a long time, when the industry seems to call it CCI, co-channel interference, I'm happy to go along with that terminology. But it confuses people. If I'm teaching classes, the first time I say yes, and then you get co-channel interference, and then the very first thing I then have to explain is, well, it's not actually interference, it's actually the fact that you contend with each other. And if a term needs explanation like that, should we be using it? I'm not going to go into that argument in too much detail today. That was just something to throw out there. But wouldn't it be nice if we could all agree? Wouldn't it be great if we could come up with something where we could all agree, in a broad way, a broad sort of design framework? So I've got my next poll question I'd like to throw up now. We all agree that gathering the requirements should be the first part of the design. So what should be the final part of the wireless design lifecycle? Is it validation, diagnose, optimization, or training? We'll leave that poll for a little bit. What's the final part of the wireless and design lifecycle?
Looks like we've got two clear front runners in this one.
Oh, brilliant.
Five more seconds. Okay. So almost a dead heat between validation and optimization. Just 1% of people think it's diagnosed, 13% said training.
Brilliant. I love those results for lots of reasons. So that's excellent. So it's a dead heat between validation and optimization. People can't quite decide what it should be. And that's interesting because I think it exposes something which I think has been there for a long time when we talk about wireless and design cycle, is that we've struggled with the final phase on what it is and what we actually should do. And validation and optimization has been thrown about quite a lot. Well, I want to show you this diagram, which got debated quite a lot as well, which had define, design, deploy, and diagnose. Now, this was first deployed as a way up there. Well, if we've got 4 Ds, it's easy to remember. So if what we're talking about is we want to come up with something that's easy and good and easy to teach people, we don't want to be confusing, 4 Ds is quite easy to remember. The problem is we then, and this is me personally, have a problem with its word, diagnose. Is it the right word? Because it doesn't really say what we want. And I think that's because for a long time we've seen validate as the final phase. But then some people go, well, actually, after you validate, you then optimize. So is it better that, because we've already talked about language and language should be clear and understandable, let's not worry about 4 Ds. Let's have define, design, deploy, and validate. But again, there's a problem with validation being there, I think. And it was actually a discussion with Keith that helped me to come to this conclusion, is that what are you validating in terms of a life cycle of a wireless network? Do you not validate at the design stage? If you do a RF model, you may choose to then do an API on a stick of your RF model to validate your design. And we do that at the design stage. When you deploy a wireless network, we should validate the deployment, which I think is what a lot of people mean when they put validate here. But is actually that not part of the deployment? You install your APs and then you do a validation survey. You are validating that deployment. You make sure the APs are inside. You're saying, this is what the deployed wireless network looks like. So, and actually, when you gather your requirements, you should validate you've got them right. You should say, look, these are the requirements and agree them with the customer before you do a design, otherwise you're going to design to the wrong requirements. So actually, validation is part of every step, you see. So maybe our life cycle removes validation completely. Because actually we validate the deployment, we validate the design, we can validate the requirement, the gathering, the defining the requirements. So we then get to our 3 stages. But how often nowadays do we do this? How often do we come in to a customer who goes, right, I need you to design me a network. Okay, let's sit down and define the requirements. And you're designing a completely new wireless network. A lot of this assumes you're designing a new network. But very often a network already exists, doesn't it? And very often we're being brought in to assess the existing network to determine, does it meet the current requirements? Not necessarily the requirements it was originally designed for, but is it meeting what's currently the requirements? Let's assess or diagnose a current network, and then we can determine, maybe from that might be you need a full new Wi-Fi design, or maybe it might just be you need a couple of extra access points, or maybe you're good for coverage, but you need more for capacity. So very often we come in to, and the first thing we're going to do is assess what's already there, or could you say diagnose what's already there? In which case, can we add our third D back in and go define, design, deploy, diagnose? And for someone personally, I never liked the word diagnose initially. I've warmed to this idea that validation should be part of every stage. And if we do that, then actually there is a point where we need to diagnose what's currently there. And that's just as much part of design as other things. So I want to sort of propose that these are 4 general stages that we could potentially agree on as an industry. And I'm not calling diagnose, I'm not saying diagnose is validation, that's important to understand. Validation is actually part of deployment, it's part of design, it's part of define. So can we agree? One final quick poll then, just to, I thought would be fun to do on RRM, Radio Resource Management, automatic channel and power settings. I thought when we talk about design, we've got to talk about it. So question is, which is true regarding RRM? Does RRM render the entire design process irrelevant? A wireless LAN design should dictate the RRM settings, always use static and power channel and power settings, or what is RRM? Maybe we don't even know what it is. Let's just quickly answer that question.
All righty. There's a clear leader here. I think this might be the most unified the audience have been.
Okay, I'll be really interested what it is.
Oh, although, yeah. Okay, right. Here we go. So we've got 18% of people saying what is RRM, but of the other people, 72% said that it should the design should dictate the RRM settings, and then 4 and 6% for the other two.
See, I love that. I love our audience today. What a smart answer. It's probably the one I would have gone for as well. If I had to pick an answer to this one. The reason I wanted to ask the question, though, was because I think RRM is another example of where arguing in our industry has caused confusion. You know, you've got Bob saying you should always use static channel powers, you shouldn't do it, and then you've got Bill saying, no, RRM is brilliant, it's just you don't understand how to design for it. But what neither party says is, well, how do you design for RRM? How do you design a static channel plan? No, we just argue over what you're doing. And the truth is, I'm comfortable with static channel and power settings. I'm comfortable with RRM, but we need to understand and communicate with people that if you do choose RRM, how do you design for it? Because the design should dictate what the RRM settings is. And over the last 3 years, when I've been assessing wireless networks, the biggest issue I've seen is default RRM settings. And the biggest problem, the way I fix most of them, is setting a minimum transmit power in the RRM settings. You see, when you do a wireless LAN design, you design your APs at a certain power level. If you allow your APs to go below that power level, you're going to create coverage holes. You're going to create secondary coverage holes, primary coverage holes. So don't allow it. Whatever you design, make sure that's the minimum power settings. And it's things like that we should be communicating, not arguing over is static, is RRM better. We need to be informing people, how do you design for RRM? How do you design for static? And that's just really the last thing I wanted to say. So I believe that we can and we should aim to try and have a unified language that we can all agree on. Will it be your language? No. Will it necessarily be my language, preferred language? Probably not. But it has to be a language that isn't confusing, that's clear, that we can all agree on, and therefore we can use to try and help have good Wi-Fi. So let's agree to agree so that we can say goodbye to bad Wi-Fi. And that is all I have to say. Thank you very much.